In this video, I'm going to examine a probability model. I have some possible values on a return on investment of some kind and the various probabilities of their happening. I need to get these values in as lists, so I hit my stat key, edit. I already have values in L1 and L2, so I'm going to put these in L3 and L4 just the way we see them. 0.15, 0.35, 0.35, and 0.15. Next to it, are the possible returns, which 9, 13, 16, and 20. Now it really makes no difference in which order I enter these returns, but wherever I put the 9, I must match it up with the 0.15. Wherever I put the 13, I must match it up with the 0.35, and so forth. Now what I'd like to do is to get a weighted average of these possible values. So at this point I will go second, quit. I go to stat to calculate, and I entered values in two different lists, so it would seem like option 2 var stats would be appropriate here. But in fact, return is the only variable, so I want 1 var stats. Some of the newer model calculators have a nice little form that you fill out on the screen, and it instructs you where to put your information. My older model is not quite so friendly. I put my possible values. Let's see, where did I put the possible values in L4 and their respective probabilities in L3. So let me go back to my second L3, comma, second, no, I'm sorry, that's second L4, comma, second L3. This first list is where my possible values reside. The second list are their respective probabilities. And I hit enter. X bar is shorthand for expected value or mean, and that's the calculations for that are fairly reasonable. Just each of these values multiplied together and then summed, and that's where the 14.5 comes from. Further down, this value is the standard deviation. The calculations for that are quite a bit more involved, and that's what they give us here. I know it's a valid or probability model because my n, which is the sum of these probabilities, is 1. And I think I'm good to go here.